Okay. So the next problem is diameter of binary tree. Uh, Now, this problem basically states that we are given a root of a binary tree, and we have to return the length of the diameter of the tree. So, diameter is what? If we look at a circle, the diameter is distance of the extreme end from the center, one side, and the distance to the other side. This combined length is known as diameter. So in the case of a binary tree, a diameter can be this, or this. So basically, distance between any two extreme ends of or leaf nodes um, of a binary tree. So yeah, so let's start. So in this case, the diameter is three. How? So this is one, this is two, this is three. The diameter could have also been one, two, but we need uh, longest path, right? So no, so this would not have been a diameter. This is a distance between two leaf nodes. The diameter is the so as we know in the case of circle also, this is also one extreme end, and this goes to the other extreme end. But uh, this is not diameter. This is something else. The one passing through the center is called the diameter. So let's start with binary tree. Um, let's see this example: one, two, three, four, five. One, two, three, four, five. So what will be the diameter? So this is a distance. This one is a distance between two leaf nodes. This is another distance between two leaf nodes, and we just have these two in this particular case. The longest one is this one, which has one, two, three diameter. Um, Now, how do we solve this programmatically? Uh, okay. So basically, what you have to do is, so you're given this root, right? So what you have to do is just get the maximum height from this side and the maximum height from this side, and just add them. So like this being um, one, two, and three. Uh, the height that this left subtree will have is one, two, two, and the height for this right subtree is one. You just have to add these two, two plus one. This gives me one length um, from leaf to leaf, and this is three. So in this case, when we have this, there's one subtree four, and the second is five. The left one will give me one, and the right one will also give me one. So in this case, the length from leaf to leaf will be two. So the maximum, the longest one will be three, and hence the diameter will be three in this case. Now let's see, how do we solve this? So what we have studied till now is how to find the height of a binary tree. So for this binary tree, the height will be three because the longest uh, distance from the root to leaf in terms of levels is three, right? Um, so what we can do is at each possible level, at each possible node, um, calculate the height of the left subtree, the right subtree, and just keep a track of those additions. So L plus R at each point. So at this point, the L is 1, 2, 2, the right is 1, and in this case, the L is 1, right is 1. In this case, 0, 0, 0, 0. So this gave me L plus 1, 0. So this is 0, 0, and this portion is um, 2, and this portion is um, 2 coming from here, 1 coming from here because 0, 0, 1 because of this. Um, 2 plus 1 will be what? 3, right? So what we need to do is do the same thing at each point. So what was maximum depth or the height? You at each node keep calculating. Uh, you first of all take the root and then you add the height of the left subtree and or the right subtree based on like which one is bigger, and this way you find out the height at each level, right? So what you will do in this case is at each level when you are finding the height of left subtree and right subtree, you will also keep track of that variable, maximum diameter variable, which will be basically max of the previous value of max diameter and the addition of L plus R, right? So simply at each point you're calculating the height of left and right, you're adding one to it, and you're basically calculating the height um, of that subtree, and you're also keeping track of L plus R at each point. This will give you basically the maximum L plus R of the whole tree, which will be the diameter essentially. So let's try to do the dry run again. So in this case, 1, 2, 3, 4, 5. Again, 1, 2, 3, 4, 5. So in this case, you start from here, right? Calculate the height as 1 plus left subtree is this 2, 4, 5. 2, 4, 5. Max of this, height of this, and height of this. Okay, and you also keep a track of diameter such that L plus R, which is like 2, 2, 4, 5 plus 3 in like the height of this subtree and the height of this subtree. Now you go on to find the height of this subtree. You add the height of 2 and the maximum of left, which is 4, right, which is 5, and you also keep track of the maximum of the previous value and the left plus R, right, the maximum of previous value and L plus R, which in this case is 4 and 5, these subtrees. Um, Again, do the same thing for 4, 1 plus the height of left subtree, which is basically null, and maximum of null and null, basically. Um, and you also keep track of height of left plus R. And in the case of right, also you do the same thing. Maximum, sorry, one plus is done. The left is null and right is null. What you will do is in the case the root is null, uh, that I will discuss later on. So in the case of 5, we will do 1 plus maximum of null and null. So we had this edge case where if the root is null, you simply return 0, right? Because the root is not there, there will not be any height. Without any node, there is no height. So this null will return 0. This random will also return 0. This will return 0. This will also return 0. This will also return 0. 0. L plus R. This returns 0. This returns 0. So the value at this point is 0. This is 0. This is 0. right? This returns 1, this returns 1 because we had 1, and this return also 1 because we had 1, right? And this also returns 1, 1, and the height becomes 2 at this point. The diameter becomes L plus 2 at this point. Now the diameter is 2 and the height is also 2, right? Um, Now at this point, the height for this one is um, 2, right? And the height for this one, if we go on to do the same thing, this will basically come as 1, and the diameter uh, this will be nothing but 0 because L plus R will be 0 plus 0, and the diameter will be 0 for this case. Now the maximum is still 2, right? And um, for this case, the diameter is L plus R. This is 2. This is 1, which is 2 plus 1, 3. Diameter becomes 3, and the height becomes 1 plus 2, 3. So diameter is 3, and the height is also 3. Yeah. So this is how the diameter is done. Um, so you basically keep a track of the max diameter variable, and at each step you not only calculate the height of the subtrees but also um, the diameter at that point. So either you can use a helper function, you will have to use a helper function, but either you can create a variable here and pass it as a reference variable, or you can simply create a global variable which will be max diameter, and let's call it 0 because at the very in the very worst case scenario it will be 0 only and there is not root. So let's say if there is no root, you simply return 0, right? And other cases, what you do is you calculate uh, you basically recursively calculate the maximum diameter and then you return the max diameter. How do you calculate that? We'll use a helper function. This will just keep keep getting the heights of left and right subtrees, and this will basically give us this will also keep calculating the max diameter at each point and will give us the max diameter. So if I do private uh, um, the helper function will be integer because this will be nothing but like the height function. So let's see, it has the root, and what you do in this case is you simply say that if root is not there, then there is no height. Else you return, you add the height of root and the maximum of helper, or let's just call it height function. That will make it easier to understand. And max of helper of, sorry, not helper, but like height of root left and height of root right. Okay, and at each point you will keep a track of max diameter as max diameter and left plus right. For that, you will need left and right. So you can't do this. You'll have to move this over here and save it as, let's say, left. And you'll have to keep right also. So let's say, so left, right to keep track of. This is left, this is right. Right. So this way you have the left and right. Okay. Let's see if there is an issue. Anything. Okay. So we are missing semicolon. Okay. T naught does not refer to a value. Okay. We do not have to. We just have to pass the root only. Okay. The arrow is wrong. So many bugs. Okay. Finally accepted. Okay. So this is how it works. So since we are doing the same thing, we are basically calculating the height of left and right. The time complexity will be O of n plus O of n, which will essentially convert to O of n only. Let's generalize it. And the space complexity will be O of h. Um, in this case also. In the case of skewed one, it will be O of n.